Alright, more on ions. So looking at the periodic table, we can clearly tell what ion is going to form with what charge. All of group 1 has a positive charge, all of group 2 has a positive 2 charge. Hydrogen also forms positive charge, very similar to group 1. It's not added to group 1 because its properties are different, so we don't stack it with it, but some properties are similar, like they all form positive charges. Group 3, well, aluminium will form a 3 plus charge, and everything on the other side will form a 2 minus charge for group 6, minus charge, nothing for group 8, and I'm not too sure why this diagram is empty. You have nitrogen over here, which has a 3 minus charge, and I believe you have phosphorus over here, which can also go 3 minus. This is kind of empty because they don't really come into play. Okay. Let's do some more dot and cross diagrams of different ionic compounds. So right now you kind of should be able to tell one very important fact, that you'll have, on the left hand side you have metals, on the right hand side you have non-metals. Metals will only react with non-metals to form what? Ionic compounds. The ionic bond can only exist with something that has a positive charge and something that has a negative charge, right? Ions that form those two things. And only on the left hand side of the periodic table do you have positively charged ions. And only on the right hand side you have negatively charged ions. And they're already all metals, and these are all non-metals. It's always a mixture is the wrong word, but it's always a marriage of a metal to a non-metal that forms a ionic compound. If any time you see something like, let's say, carbon dioxide, is that an ionic compound? No, it's not, because that's a non-metal. Nope. If you see MgCl2, is that it? Well, that's a metal. That's a non-metal, right? This is ionic. What about Al2O3? Well, that's also a metal. That's correct. It's a non-metal. Yep. This is also ionic. So you can, just by looking at it, you can go like, oh, that's an ionic compound. Okay. And let's try drawing some dot and cross diagrams for a few. All right, so we have calcium over here, and we have on the other side chlorine over here, right? Now chlorine has 1, 2, 3, 4, 5, 6, 7 electrons, and it borrows 1 from calcium. But even in the chemical formula, they're telling you there are 2 chlorines. So how do we show that? We put a bracket on it. One bracket goes there on it anyway. 2 for this, and it's a bit crowded. Why do I do this? It has a 2 positive charge, and this has not a 2 negative charge, a negative charge, and that's the dot and cross for calcium chloride. Let me erase this and put calcium a bit more neatly. Okay. Now this is going to be, now magnesium fluoride, if you notice, has a 2 plus charge. Fluorine has a negative charge. The calcium over here has a 2 plus charge, and chlorine has a negative charge. In fact, magnesium is right below calcium, and fluorine is right above chlorine. And this is one of the things why the periodic table is so important. To know how one thing works, I can figure out, I don't even have to figure out, it's the exact same thing. I'll just be replacing calcium and chlorine with Mg and fluorine, because they form the same ions. It's the same relationship. It's the exact same thing. So let me try doing that. Let me show you what I mean. I have magnesium. I'll space it better this time. And fluorine over here. Fluorine again has the exact same electronic configuration. It borrows 1 from magnesium. I was meant to make this pink. I'm going to make it pink now. Pretty sure I changed the color. I think it was fast, so it didn't change. So, okay. Now, time for the brackets. has a negative charge. You have magnesium. Yeah, it looks much neater now. Okay, now magnesium will have a 2+ charge. You want twice the amount of chlorine, and that's it. Yes? Exactly identical. The only difference between the last dot and cross we did was it's Ca written over here, right? And instead of fluorine, we have chlorine. Otherwise, they're completely identical. I should also change this to actually an X, because you guys don't have color to answer this, so you make sure you differentiate. Also, you should add keys to your exam. You should say, that, hey, calcium's electron is represented by a cross, whereas chlorine's electrons are represented by a dot or a circle. I'm doing a circle because it looks nicer, I think, and it's easier for me to draw. Dot is the way to go when you're doing it in paper. Make a dot when you're doing it in paper. All of these should be dots. It looks better that way when you're doing it on paper. Take it. And this is my key. Highlight it that it's your key. Take it. Over here my key is fluorine is a dot and magnesium is a cross. Okay. Let's try for sodium. Very similar. Sodium is that. Oxygen is just an O. Okay, oxygen has 6 and it'll take 2 electrons for sodium, and I put the bracket on. I should make some room. I think I cannot put the 2 in there. Make some room. Sodium and 2+, or not 2+, it's just plus, like that. 2. Why do I go with 2? The 2 isn't there. Sodium always forms a plus ion, but there are 2 of them, and like that. Oh, I could have done it like that. Oh well. Let's try aluminum oxide, but I'll start from writing the 2 down. That should be less confusing. Aluminium, let's change the color though. We're sticking to a color code. Al, like this, 2+. Oh, aluminum is 3+ actually. And then you have oxygen with a 2- charge. But you have 3 oxygens, and each oxygen is actually blue to begin with. Oh, pink to begin with. Then it has 1, 2, 3, 4, 5, 6 of its own electrons and 2 from aluminum. But there are 3 of it each, because 2 aluminums will give out 6 electrons. 2 aluminums give out 6 electrons. So, and 3 oxygens can absorb 6 electrons. So it balances out when you have 2 aluminums for 3 oxygens. I hope this makes sense to everyone.